Hello, welcome to this video, lesson 1-2b. In this video, I'm going to talk about inverse functions and piecewise functions. So we've been talking about relations and what makes them a function. A function is said to be a one-to-one function if there's not only one y for each x, but also vice versa. So if there is only one x for each y. So visually, this will be represented by the horizontal line test, and the function, if it's one-to-one, will also pass a vertical line test. So what I'm going to do, I'm just going to go back up here to these examples in 1 through 4, and I'm just going to show you the horizontal line test. So if I draw a horizontal line here through the first example, that passes the horizontal line test, okay? And in example 2, if I draw a horizontal line through this function, through this relation, notice that it intersects at 2 x values, okay? So that, this function, well, it wasn't even a function to begin with, but it is definitely not one-to-one, right? It doesn't pass the horizontal line test. So yes, so this case would be one-to-one. Okay, one-to-one. In example 3, if I draw a horizontal line, notice again we intersect at 2 locations. So no, this is not one-to-one, does not pass the horizontal line test. In example 4, notice if I, if I draw a horizontal line through, okay, at any point, I pass the horizontal line test. Okay, it only intersects at one spot. Okay, so out of these, right? No, not a function. Passes the horizontal line test here. It's a function. However, it does not pass the horizontal line test. This one, no, no. So example 1 is the only one with yes, yes. So example 1 is a one-to-one function. So why does this matter? Well, I want to talk about also with functions, we have inverse functions, okay? And this is found by switching x and y and solving for the new y, okay? And remember the symbol notation here is f inverse of x, okay? So here it says only one-to-one functions have inverse functions. Since x and y are switched to produce inverse functions, the domain of f becomes the range, right? And the range becomes the domain. Okay, and an example here would be is if a comma b is in the function f, then its inverse would be b comma a. So example 12, it says which of the relations in examples 1 through 4 is a function with an inverse function, okay? And again, we can tell if the inverse is a function by the horizontal line test. So we go here, right? And our only 2 functions were examples 1 and examples 3. And the only one that had an inverse that is a function would be example 1, okay? So down here we can say example 1. So example 13, they want us to find the inverse of f of x algebraically. So again, remember what you have to do first is you have to switch your x and y. Okay, so if I rewrite this function over here as y is equal to 2x cubed minus 1, and I swap my values, so I get x is equal to 2 y cubed minus 1, okay, and I can solve for y. So I get x plus 1 is equal to 2 y cubed. We'll divide by 2, so x plus 1 divided by 2 is equal to y cubed, right? And then step 2, which we're doing, solve for y. I can take the cubic root, and we get y is equal to the cubic root of x plus 1 over 2. Okay, so this would be the inverse. Remember, we want to set this in inverse notation. So f inverse of x is equal to the cubic root of x plus 1 over 2. Okay, so that is a little bit about inverse functions and about one-to-one functions. Okay, the next topic I'm going to talk about is piecewise functions. A piecewise function is a function defined differently for different pieces of its domain. And here's an example of a piecewise function, and notice that it's kind of split over here on the right-hand side by its domain. And what this says is if your domain is less than or equal to 0 here, you're going to use this function. So we can look over here, right? Here is x is less than or equal to 0, okay? And I use that function. Y is equal to x. For the next piece of the function here, okay, between 0 and 1, non-inclusive, I use the function 2 minus x, okay? And that would be this little segment here, okay? And for the third part, for x is greater than or equal to 1, we use x squared, okay? And that's how we get this portion here. So that is piecewise functions. Okay, so if we go to example 14, they want us to graph the piecewise function and then give the domain and the range. Well, remember with piecewise functions, your domain is given here. Okay, so for values less than 1, I'm going to use this function. For values greater than or equal to 1, I'm going to use this value. So notice how all real x values are given. Okay, so our domain would be negative infinity to positive infinity. Okay, all real numbers. And what we want to do in order to determine the range, we want to graph this, okay? So what we're going to do is we're going to go over to 1. And when I'm graphing, I like to make a chart. Okay, so I'll just put 1 in the middle. And at 1, right, and remember not including 1, I'm going to get the absolute value of x. So if I plug in 1, the absolute value of 1 is 1. So I'm going to go to 1, 1. Here, and I'm going to put an open dot, right? Because I'm not including that value. And then to the left, my y value is just going to be my x value. So at 0, 0. At negative 1, it's the absolute value of that. So that's positive 1, right? 0, 0. Negative 1 is positive 1. So on and so forth. So I get this graph for values less than 1. As soon as I go greater than or equal to 1, I get x plus 2. So if I plug in 1, right, if I plug in 1 here, I get 1 plus 2. So that gives me 3. So at 1, 3, I get this point. Okay, and that's just going to be a straight line. Right, so I have my graph, okay? And there is my piecewise graph. The range, the outputs, notice that I go from 0, so I have a value at 0, so I'll use a bracket, 0 all the way up to 2. Well, actually, if I keep going on the left, I'm gonna, sorry, bad notation, I should put an arrow up here. Okay, it's going to keep going up. So all y values covered all the way to positive infinity. So positive infinity. Okay, and that is the range. All right. In this video, we talked about one-to-one functions, how to identify a one-to-one function. Remember, a one-to-one function is a relation which is a function, and its inverse, right, found by switching x and y, is also a function. Okay, and then we also talked about piecewise functions.